Hi everybody. So it's a funny thing, but half the time we don't do things because they're the best thing to do. We do them just because we're used to them. These things are a good example. The reason they're like this is because they're like this. And we've been using them for 100 years and we're just used to them. And resistance to change is enormous. The problem with cranks is that when you're at the top, you're pushing straight against the crank, and what you need to do is slide your foot. Otherwise you lose a tremendous amount of power in that pushing. There was, during the 80s, something called the biocycle, which was an elliptical crank to try to help you overcome that push. But it is still a real issue. And along came these guys to save the day. The Singer has a secret weapon, and that secret weapon is the treadle. The treadle takes that push and turns it into a rotary motion. But because you're not pushing straight down, treadles, cranks can transfer up to 5 times the torque. Then Singer came along, and they brought with them this. It's actually a crank mechanism from their Treadle sewing machine, and what it does is it turns that up and down push motion into a rotation. Now this particular machine is the extraordinary penny farthing. Having a crank there means you can put the seat further back and you're less likely to come head over heels over the handlebars. Of course, these things weren't just restricted to sewing machines and bicycles. They found widespread use in the railways, where they were used to push a vehicle along, known as pump trolleys or pump carts or jiggers or rail velocipedes, a whole host of names for exactly the same thing. And they came in 3 or 4-wheeled versions and were able to carry one person up to a huge crowd. Now, in railway terms, they were quite light. In real terms, of course, they were extremely heavy, and that mechanism has been used so often because of its efficiency at transferring power. Given this is supposed to be great for the transmission of power, and it's basically nothing more than a few links and pivots, the next thing I want to do is to see if we can turn it into a way for generating power. So I drew this up in Tinkercad, and it's pretty simple really. If I print off the disc, which I've got here, and I put a load of magnets around the edge in a north-south configuration, and of course the disc sits in that cradle, and that's what we're going to spin. Now the cradle has a couple of 12mm by 6mm by 4mm bearings. So the holes in the the hole in the center is 6mm, so it takes a 6mm piece of steel, and it's 12mm on the outside. So we only need 4 of those bearings. But stick 2 of them in that cradle, pop that in there with its magnets on, and what I've got here is a bit of 6mm bar that's going to protrude out once I get it stuck through there. There it is, nice and free to turn. Now, of course, what I want to do is put the cranks on. The cranks are these bits here, and they've got a connecting rod, and in there is where the other bearing goes. And there's 2 of those. There we go. There's 2 of them, and they fit on there through that central hole. One thing to note, if that's at top dead center and you turn it round, the other one is 90 degrees that way, so you fix them in that way. Now I put them on the 6mm bar and a spot of super glue. It's fine for what we're wanting to do. Now we need to attach these, which are the pivot cranks, to here, and they go that way around with the small one facing outward, because this whole lot is going to go in that box. For the pivot on that, what we're using is some pins. These are 10cm long, 2mm pins, and they just go onto that pivot like that. If it's a little bit tight, you may need to drill it out with a 2.5mm drill, and those 2 pivots go on the back there. When you've done that, they feed in there like that. This is the pivot pin we're going to use. It's 50mm by 2mm, and it's going to go through there, which is the point at which it pivots. You'll notice on the side of the box there are some corresponding holes. Again, if those holes aren't the right size, just drill them out until they are. Okay, and that's it put together. Now I have to admit, I have a little bit of an obsession with these silly feet. I got them from Thingiverse. They're meant for a 3D printer, but I think they're really cool, and they make everything look really cool. So I've included them in my Tinkercad files. You don't have to search for them, but if you want to search for them, they're actually just available on Thingiverse. Now this is all put together. What we get a choice of doing is we can either do that, or we can do that, or we can do both together, and that obviously will spin this wheel like crazy. And of course this wheel's got magnets on, it's its own flywheel, and those magnets are in north south, so we've got a coil and we're going to see if we can get a voltage out of it. Okay, to help me do this, we've got Luke, guest appearance, and the camera, the meter's right here, but I'm going to ask Luke what it is anyway, because I can't see Jack. And what I'm going to do is waggle this, and Luke's going to hold the coil next to the magnets. Shall we go, mate?
Let's do it. .3.
Really?
Yeah. Done. 1.5. 1.6.
Okay, that's really cool. It's one coil. I mean, we could put a serpentine coil around there and we get some really great output. We could gear this, because remember, I'm at no effort at all to do that, hey? And remember, these transmit torque really well. So we could gear it as well. And there's a ton of things you can do with something like that, but that simple crank mechanism can be built into a generator, no worries at all. And this backwards forwards motion, oh, you see that a lot. You see that when you're walking, for instance. If you've got a backpack on and you put these in your shoes, you're going to be generating as you walk. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.